those build-up stresses on the faults themselves. So between earthquakes, in the far field away from tectonic faults, tectonic plates are moving, and those build up stresses on the faults themselves. So between earthquakes, those faults are stuck by friction. There's movement at depth in the earth, but the top 15 kilometers are stuck by friction, and you get essentially an elastic warping. It's just like if you're bending a ruler across that fault. Okay, that keeps on happening, until eventually some critical threshold is reached, and then suddenly that shallow part of a fault slips suddenly, all that elastic energy that's built up is released, and you get an earthquake.
And so you want to be able to map, almost in real time, this very slight bending and buckling that's going on.
Exactly. So we're trying to measure this elastic warping, this slow elastic warping of the Earth's crust. And that tells us, because it's an energy balance, the amount of elastic energy that builds up is the amount that is available to be released in earthquakes. And that relates to the size of earthquakes and the frequency of earthquakes we expect in any tectonic region. So by measuring this elastic warping, that tells us something about seismic hazard.
Now, when an earthquake happens, of course, the ground can move by several meters, can't it? But what you're talking about is seeing something that's on the millimeter scale, yes?
Yeah, absolutely. So on a fast fault, like the North Anatolian Fault in Turkey, this is about 2.5 centimeters per year. So that's about 2/3 of the rate that your fingernails grow. And this is taking place over a length scale of about 100 kilometers. Okay, so this is over a long distance, a very sort of gentle warping of the Earth's crust. You wouldn't be able to tell if your house was built on top of this. Okay, and that's actually very difficult to measure with the satellite techniques that we typically use to measure earthquakes. If we're trying to measure a displacement of a meter from the satellites, that's actually pretty straightforward. Okay, the noise that is unfortunately, part of these measurements is often at the several centimeters level. So when we're trying to measure a displacement that's only a few centimeters, or even worse than that, a few millimeters over a space of